Section 6.2.46. Okay, now, according to the report, 65.9% of murders are committed with a firearm. In Part A, if 200 murders are randomly selected, how many would we expect to be committed with a firearm? Okay, now note that the mean of a random variable can be interpreted as the expected number of successes in n trials of an experiment. So to find the mean, recall that a binomial experiment with n independent trials and probability of success p has a mean given by the following formula. So we know that the mean is going to equal n times p. Okay, so now we need to determine what is n and what is p in our problem. Well, we know that n is equal to 200. And we know that the probability is 65.9%, which converting to a decimal is 0.659. Okay, so now we're going to go ahead and calculate the mean. So we know that the mean is going to equal n times p. We know that n again is 200. And we know that p is 0.659. which gives us the value of 131.8. And so, therefore, we would say that if 200 murders are randomly selected, we would expect 131.8 of them to be committed with a firearm. Okay, now in Part B, it says, would it be unusual to observe 153 murders by firearm in a random sample of 200 murders, and why? Well, note that as the number of trials n in a binomial experiment increases, the probability distribution of the random variable x becomes bell-shaped. As a rule of thumb, if n times p times 1 minus p is greater than or equal to 10, the probability distribution will be approximately bell-shaped. So in this case, we know that n, okay, is 200. We're multiplying it by the probability of from 0.659. And then that's going to be 1 minus 0.659. Well, that's equal to 44.9438, which is greater than or equal to 10. Therefore, the probability distribution is approximately bell-shaped. Now, since the probability distribution is bell-shaped, the empirical rule can be used to identify unusual observations. Recall that the empirical rule states that in a bell-shaped distribution, about 95% of all observations lie within 2 standard deviations of the mean. That is, about 95% of the observations lie between the following. It lies between mu minus 2 times the standard deviation, and then mu plus 2 times the standard deviation. Now, in order to find mu minus 2 times the standard deviation and mu plus 2 times the standard deviation, we need to first find the standard deviation of the binomial experiment. And recall that a binomial experiment with n independent trials and probability of success p has a standard deviation given by the following formula. Okay, so the formula we know of the standard deviation is equal to the square root of np times 1 minus p. Okay, so let's go ahead and find that. So we know that the standard deviation is going to be the square root of 200 times 0.659 times 1 minus 0.659, and then taking the square root of that number. So we take the square root of the number that we found, which is 44.9438, and then we're going to round that to 2 decimal places, and that gives us 6.7. Okay, now in order for us to determine if it would be unusual to observe 153 murders by firearm in a random sample of 200 murders, we're going to calculate the following. So we're going to say, okay, we're going to take mu minus 2 times the standard deviation. So that means that we have 131.8 from the beginning part minus 2 times the standard deviation of 6.7. And so when we do that, we end up getting 118.4. And we define mu plus 2 times the standard deviation. So that's 131.8 plus 2 times 6.7, which gives us 145.2. Okay? So, we would say the following. We would say that, therefore, any value that is less than 118.4 or greater than 145.2 is unusual. Well, 153 is above that, so therefore it would be considered unusual.